Very good morning, students. Welcome back to the session 6 on multi-threading. Here, I'll be focusing on the synchronization between the threads. So first, let us try to understand what is meant by synchronization. Synchronization means you should complete one particular task and give it or deliver to somebody else to carry the work. Take an example of multiple threads running in the system. Make an assumption of a printing job where multiple threads are running in the system. If thread 1 is also printing and thread 2 is also printing and thread 3 is also printing. Assuming that you have given a one-page document for the printing. Suppose the job of all the three threads is to print the document, and all the three processes are competing for the CPU to send the instructions to the printer for printing certain set of lines. Maybe in one page document, say 25 to 30 lines of data is there. Assume that take a 30 lines, and if the same task is given to all the three processes, and each of the processes should give an instruction for the printer to print this content. What happens if all the three processes are competing for the central processing unit to carry their job, and based on the scheduling of the threads, so thread 1 may take a chance to complete its job for certain amount of time, then followed by thread 2, then followed by thread 3, or the order it may be thread 3 followed by thread 1 followed by thread 2. It can be any one order. It can be any random order. What we have seen in the previous executions, order is not in our control. So based on the load of the CPU will schedule the threads by using the appropriate thread scheduling algorithms. So thread scheduling algorithms may be first come first serve, or it may be a round robin, or priority scheduling, shortest job first, or whatever. Now, what happens in such cases, if one of the thread is started, assume that it has been printed 6 lines of data. Thread 1, it is printing the first 6 lines of your document, and if a thread 1 is preempted by the thread 3, and it may start with printing the directly from 21st line to 27th line. Just make an assumption. So after printing the first 6 lines, directly your document is printing the 21 to 27 lines, which is the very the imbalanced outcome of your printing job, inappropriate outcome of your printing job, which you cannot read, and thing will not serve the purpose. So which is a one erroneous problem may occur due to the multi-threading if the threads are not synchronized. Coming to the this printing job of synchronization, what I will do, I will give the controlling of the printer completely to a one specific thread, so that it completes its printing job from line number 1 to line number 30 and finish its job. Then give the chance to the some other thread, maybe a thread 3 or a thread 2 or whatever. So that ordering or the sequencing of the tasks to be followed, it is retained. Because for some sort of jobs, so sequencing or ordering is which is very, very, very important. So in the similar case, here we should be very careful when we are dealing with the multiple threads and the tasks are assigned. So for these kind of problems, So we need to synchronize the threads in order to get the appropriate outcome as a result of your uh, the execution of the threads. So that indicates the completion of the job properly. So this is what the one major problem if the threads are not synchronized. If you synchronize, then things will be fine and nothing will happen. You'll get a appropriate output. So this is one of the disadvantage if the threads are not synchronized. So if it is synchronized, you will get a appropriate output. Okay, after discussing what is mean by the synchronization, we will try to understand what is mean by monitor. Monitor, which is one of the programming tool which is used to give the complete resource to a one particular thread. It is just like you have a one box where you keep your the key inside that box, and unless that key is taken, the next key cannot be placed in that box. So it is just a random example I'm considering. It is very confidential space. If thread 1 enters a monitor, others are not allowed unless a thread 1 completes, or vice versa. It can be a thread 2 or a thread 3. So monitor, it is a programming tool where one of the thread can enter into the monitor, which means that the complete resource will be taken by the thread 1 only. At that point of time, when a thread 1 enters a monitor, thread 2 and thread 3 cannot perform any job with respect to the job that is mentioned, or that is job that is shared among the three threads. This is very important. In operating system also, in order to achieve the synchronization, we will use many tools. Among that, one is a monitor, which is a general understanding of synchronization and how do we achieve the synchronization with respect to the threads, the part of your operating system. The next question: how exactly we achieve all these functionalities in Java programming? Of course, each and every object in Java programming will come along with the synchronized modules. So almost all objects you can take it as the synchronized modules. So we have a syntactical couple of statements to be used to make a particular resource assigned only to a specific thread, which means you can make a thread to enter into the monitor. At that point of time, other threads should wait. And once the thread 1 completes, thread 2 or thread 3 may take a chance to complete their jobs, and they can continue with their job. So it can be achieved in Java programming using two things. One is using synchronized method, and another one is using the synchronized blocks. So let's go with only one presentation slide, which is which I raise the couple of questions as well as the formal definition of synchronization, and after that directly will fall into the example, programming example, because rather than discussing more about the syntactical aspects of it, we'll go through the practical scenario where we do the synchronization using a synchronized block and a synchronized method with the programming example in the Eclipse. So also we call it as a producer consumer problem. So I'll be sharing the screen in order to understand the synchronization. Okay. So formally we can define synchronization as when two or more threads needs to access the same resource. They need to have some way to ensure that that resource will be used by only one thread at a time. And this mechanism, we call it as synchronization. Take an example of a printing job. If two or more threads are competing for taking the ownership of the printer to finish their printing job, then if one thread is doing, other threads should wait. And the entire mechanism, we call it as a synchronization. Have been explained, if the threads are not synchronized, what happens? Race condition, which means if you have only one printer resource and if 5 or 6 people are started requesting, and if the threads are not scheduled, what happens? So person one is printing a document one, the content may be mixed with the second document, and it may be mixed with the third or whatever. So you'll not get the appropriate output of the job you're going to do. So to avoid that, there should be some sort of ordering of the threads to complete that job. So for that, a printer resource and a file to be printed are the key resources, and you can make a threads to enter into the monitor, so that the printer can be used by only one thread at a time. It may be a faster context switch between thread 1 and thread 2 and so on. So immediately followed by the thread 5, followed by 3, followed by 7, followed by 1, followed by 2. Order may be anything, but that ordering also depends on the scheduling. So which thread scheduling algorithm is used, based on that you can schedule the threads. So this is what the practical difficulty or the issue we face if the threads are not synchronized. Next question is how exactly we synchronize the threads. As I mentioned in the beginning, so threads can be synchronized in Java using two different techniques. One is by using synchronized method, and the second technique is synchronized block or synchronized statement. If a method is synchronized, which means a set of tasks. Now if you take a method itself as a resource, and that method need to be entered into the monitor. So you can make a method to enter into the monitor. If that method is performing the job or executing instructions, other methods or other threads trying to access the same method should wait until it comes out from the monitor. Take an example of method itself. It is a resource associated with each thread. If a method is entered into the monitor, unless a method with respect to the thread 1 comes out from the monitor, all other threads should wait. Once it comes out from the monitor, other threads may take a chance for doing their job. And I'll be demonstrating with the practical example of printing the strings with a couple of square brackets in order to define the ordering of it using a synchronized method, and also I'll try to change the code similarly for the synchronized statement. These are only the just syntactical flexibility we have for synchronizing the threads. I hope the concept is clear, and we are ready to implement the synchronized methods in Java. So let's go to the Eclipse hands-on experiment quickly. So in order to understand the basics of it, because the class name and the method name has a bit similarity, I will try to clarify on that so that you can understand synchronized concept in a much better way. So I'll be sharing the Eclipse screen in order to demonstrate the synchronized method and a synchronized statement. Yeah. So here it is the example that I'm taking, synchronized demo, synchronization demo. Okay. So here it is a program for illustrating a synchronization. Here we have a call me method, caller method, sync demo, and I'll just make threads to wait for some extent. Okay. So as I mentioned, there are two techniques. First, I will comment this. I'll try to show the output first so that you will get an idea. Yeah. So you can notice there is a uh, the shuffling of the data while printing, and if it is synchronized, show it synchronized and non-synchronized. So if you see the output for the synchronized, yeah. So this is what the actual output I'm expecting when we are dealing with the multiple threads. When we are created with the multiple threads, so this is my actual expected output. I mean, first string hello should be within a pair of square brackets, and second string word should be within a pair of square brackets, and the third string called synchronized should be within a pair of square brackets. So this is what I'm expecting as an output, the appropriate ordering. If it is not synchronized, things may get shuffled. You may not get the appropriate output. So I will comment the synchronized code and I will run. We'll show the output first. So can you observe a square bracket is coming followed by synchronized. Here we are expecting a right square bracket which is not there, and again it is taking a left square bracket, which means the other thread took a chance to do the printing job, and after that the word is displayed, and again we are expecting the right square bracket which is not there, and again thread 3 took a chance, something like that. So the task or the things are jumbled here. We're not getting the expected output. So I mean, one thread is producing, but other thread is not consuming. so it is not synchronized. So in order to make the threads to synchronized to achieve the producer consumer concept, we should do like this. Here I'm doing a couple of things. So we'll go through these ones one by one, nothing to worry. So we'll go through the each and every element of it. How do we synchronize it? Okay, as I told, there are two techniques for synchronizing the threads. The one is by defining a method as synchronized method, and other one is make a particular block as a synchronized block. I mean, one is synchronized method and another one is a synchronized block or a synchronized statement. First, I will take it up for the synchronized statement or a synchronized block. Okay, let us go through the task first. Tasks assigned for the thread. Here, how many threads we are creating? We are creating 3 threads here. One for printing the hello with the square bracket, and the second one for printing the synchronized word with the square bracket, and a third thread is for printing the a word with a pair of square brackets around it. So 3 threads were operating here, and we'll go through the tasks to be performed here. Okay, I'm defining a class called call me. This is the first class that I'm going to define. Here what I'm doing, here only purely a method that is to be synchronized I'm writing here, and this is what the entity to be synchronized, and which has no related with the thread related libraries. Of course, I'm making the thread to sleep for some time, and which is the task what we defined here, that is printing the job. Whatever the string we give, the parameter what we are getting here, that is a message, this has to be printed. How? At the left side of the message that you are going to print should be started with the left square bracket and ends with the right square bracket. As I'm making the thread to sleep for some time, the reason is very simple. The context switch between the threads is very fast. If there is a context switch, you cannot notice what is going on there. Just to observe the mechanism, how the things are printing, we are introducing a delay for the thread. So in order to introduce the delay for the execution of the instructions assigned for that thread, you have to make the thread to sleep for some time. So for that, you should use a library function called thread.sleep of 1000. When you are using the thread related libraries like the sleep and wait, as I mentioned in earlier classes, always it throws the interrupted exception, which means in this duration, if any other thread comes and interrupts, then that leads to interrupted exception, and you just handle that exception. Handle that exception, print a message, so and so thread is interrupted. Hope the content is clear. This is the task to be performed, that is printing a string what it has received within a pair of square brackets. Very simple. So starts with the left square bracket and ends with the right square bracket. In between, the delay is introduced. That's all. It's a task. Next, we'll define another class called caller. Now, don't get confused with the class name. This is call me. Call me means it is a class where I have defined my method, and the name of the method is a call. Next, I'll define another class called caller. Here it is a thing where I'm creating the threads. I mean, code required for creating the thread, and all that I'm doing it here. Class caller implements runnable. I'm using a second technique for creating the threads here, that is by implementing a runnable interface in a class. So list out the instance variables, string message, call me target. Why I need this reference variable? Because I need to make a call to the resource, that is nothing but our method that we defined in a previous class and a method. In order to make a call to that method, I need an object of the class call me, and this message is required. I have to get it from the main function, and again I'm sending it as a parameter. Write a constructor for this caller. What are the things I'm doing here? Target is equal to target. Target is equal to targ. This object I'm getting from the main method. You can observe. So call me object I'm getting from the main method. So target. So that target in turn it is used to make a call to the method. So target is equal to targ, and message whatever you received you try to assign to message variable, and as usual the thread what you have created you need to attach it to the thread object, and after that you have to make a thread to start t dot start, and once it starts obviously it makes a call to the method. It is target dot call of message. Call is a method of the class call me, and you should have an object of the class call me to make a call to the call method. Whatever the target we receive here, it is an object of the class call me. So target dot call of message. Whatever the message you have received from the main function, you just forward to that method in order to print the string within a pair of square brackets. Yeah. Hope it is clear with the class that is defined for creating the thread. Here it comes. Here we comes with the main method. I'm defining another class called sync demo. Create an object of the class call me, that is for the resource. This is your call me class is a resource. Then followed by create the 3 different threads, that is from the caller. This is your caller class. Create 3 objects, and all the 3 resources should attach with a single resource, that is your the call method. The call method that is associated with the call me object. So create an object of the class call me, and through this target object we are trying to access or trying to make a call to the call method. Okay, now create the 3 objects of the class caller for creating a 3 different threads, and also you should pass the object of this class as an argument for each of these objects gets created, that is a thread creation, because in turn it should make a call to the call method. So we should have an object of the class target in all the 3 cases, and also the message is to be printed is passed as the argument here. So first hello thread 1, hello thread 2 synchronized, thread 3 is word, and each of these words should be printed within a pair of square brackets. That is a task to be done, and it will be done by the call method of your call me class. Okay, let's do the things. ob1 is my thread 1 dot t dot join. So t is a variable that is associated with your caller object. This is a t, and obn dot t dot join. It means if t1 completes, you just wait, and then again thread 2 wait, and thread 3 wait. Of course, in between there is a context switch among this, because as I have not synchronized, so in between there will be a context switch among all the 3 threads here. And of course, when you are making the call to the join method, mandatorily you have to handle the interrupt exception, as I mentioned before. Let's see the output. Now at this situation or a scenario, you have not synchronized. So run the output. So you're not getting the expected output here. I'm expecting around each word there should be a pair of square bracket, that I'm not getting here. Now next, why it is coming like this? It is coming because the threads are not synchronized. After printing the left square bracket and HELLO, a right square bracket should come. Before the right square bracket gets printed, and second thread took a chance, it started printing with the left square bracket and the synchronized. Then followed by, before the right square bracket of the second thread gets printed, a third thread took a chance, it started printing the string, that is the left square bracket followed by the third string and followed by the right square bracket, and again thread 2 took a chance, and thread 3 took a chance to close the square bracket. This is what the jumbling is happening in this example. To overcome this, very simple, from you have to make the a synchronized block or a synchronized statement. So what you do here, target dot call. So your resource is a call method. From where you are calling the target method, you are calling from the run method. So this statement, I will make this function call enter into the monitor. How can I make it to enter into the monitor? Is as simple as it is. You have to define a synchronized block. How can you define a synchronized block? Use the keyword synchronized of the object that is to be entered into the monitor. Once it enters the monitor, and it can make a call to the call method along with the message. Very simple syntax it is, which is the one can be used. And now we'll explore the output. We'll try to see the output now. Yeah. So left square bracket followed by synchronized word, then followed by the right square bracket. And again, second string left square bracket followed by the hello and followed by the right square bracket. And again, left square bracket and the third word, hello word, I mean just a word, then followed by the right square bracket. Now we are satisfied with this output, and I'm getting the expected output without any hurdles. So this is a one technique in order to synchronize. And another technique is the method you have to make it as a synchronized method. This is what we call it as a synchronized block or a synchronized statement. But if I comment these two lines of code, still the threads are not synchronized. Again, I'm getting the same output. Then how can I make the method as a synchronized method? So make the call method as synchronized while make the method itself as a synchronized method. This is only the thing you have to do in order to make the thread synchronized. Now check the output. Check the output, and again threads are said to be synchronized. Very, very, very important. Most of the time, the most common mistake the student do while writing the answers, first they have to write the entire program without synchronization, and they have to write the output, followed by they have to synchronize, and again they should write the output, so that you can prove all the threads are synchronized. The most common mistake most of the students do while writing the answers in the exam, most of the time they will miss this word. After synchronization, they will write it as the synchronized program. Then they'll write each and everything, and they will write to they will forget to write this synchronized word as a prefix for the resource or asset. Or for the second case, for the first case, they will forget to include this synchronized block. Either that or this, any one technique can be used in order to synchronize the threads. So here it is. There's a couple of concepts from the multi-threading. So this is synchronization, which is a very, very important topic and a critical topic, which is essential for your placements as well. Most of the time they will try to dig from the synchronized concept, and how do you synchronize the threads and how exactly it works. Here you can take this as an example, and you can present yourself, so in order to clarify the concept. So this completes the multi-threading part of your module 3. Then further, we'll move on to the strings in the next session. Thank you.